Hello everyone, welcome to Creation Stories. Today we are going to talk about Big Bang. What is Big Bang? How it's all happened, and the creation story of everything in our universe. And also we will talk about inflation theory, how it's worked together with Big Bang to explain the situation at the moment of Big Bang. The idea of Big Bang was first surfaced in 1927 by a Belgian priest named Georges Lemaitre. Lemaitre proposed that universe started just as a single point, and from that point on it's expanded and stretched to the level as we see it now. It states that around 13.7 billion years ago, an infinitely small hot, dense ball appeared, which gave rise to space, matter, and energy. Big Bang model is based on cosmological principles, which assumes that matter in the universe is uniformly distributed on all scales, large and medium. This is very useful approximation that allow one to develop the basic understanding of Big Bang. Although it was very unique and radical idea at its time, but Big Bang model is not complete. For example, it does not explain why the universe is so uniform on the very largest scales, or indeed why it's non-uniform on smaller scale. And also, it does not make any attempt to answer the question how the structures like stars and galaxies came to exist in the universe. To answer these questions, in 1979, an astronomer, Alan Guth, and his associates proposed inflation theory. He proposed that in extremely short space and time, less than thousands of a second, the universe grew 100 trillion times. Yes, 5 times trillions. Before the more gradual Big Bang expansion. Before the inflation, there was a single force that was governing all universe interaction called superforce. With inflation, superforce breaks into gravity and electromagnetic force, and nuclear interaction started to happen. Universe matter was created. Initially, universe was hodgepodge of particles interacted one another due to high level of radiations. Later, once universe had inflated, quarks formed the nuclei of the elements, and with electron atoms were formed. This screen illustration, as you are seeing in your screens, explains the first few minutes of creation, the moment before and after the Big Bang. According to the theory, everything that currently exists was once compressed into a space smaller than nucleus of an atom, and superforce was governing all the universe. The universe experienced an immense cooling process. Superforce breaks into gravity and electromagnetic forces. Nuclear interactions begins. Due to this immense breaking process and nuclear interactions, proton and neutron were born, formed by the quarks. The universe was still dark, light was trapped in the masses of particles. Throughout this continuous process, electron and positron annihilated one another until the positron disappears. The remaining electrons go on to form the first atoms. During this process, they create the nuclei of the lightest element like helium and hydrogen. Each nucleus comprised of proton and neutrons. Neutrons decouple as a result of neutron disintegration. With a very small mass, neutrons go on to form most of universe matter. The creation of atoms and general cooling allowed the universe, which was dense and opaque, to become transparent. Photons, light particles with no mass, were free to roam the space. Radiation lost its crown as a governor of our universe. and matter was able to carve out its own destiny. Helium and hydrogen joined at atomic level to make most of the universe, stars and galaxies. This picture on your screen has been taken by Wilkinson Microwave and Isotropy Probe. Its mission was to reveal the condition as they existed in the early universe by measuring the properties of the cosmos, microwave background radiation. The content of this image tells us much about the fundamental structure of our universe. WMAP measures small variation in the temperature of the cosmic microwave background radiations. These variations are very minute. One part of the sky has a temperature of 2.7251 Kelvin, while other part of the sky has a temperature of 2.7249 Kelvin. In 1992, NASA's Cosmic Background Explorer satellite detected these tiny temperature differences on a large angular scale. WMAP measures anisotropy with much finer detail and greater sensitivity. These measurements reveal the size, matter, content, age, geometry, and the fate of our universe. They also reveal the primordial structure that grew to form galaxies and will test ideas about the origin of these primordial structures. Its measurement reveals that dark energy makes up to 72% of our universe, while dark matter is about 24% of the universe. The remaining 4.6% are the atoms, which makes all the galaxies, stars, and the planets around us. Wilkinson probe measured the composition of the matter and energy density in the universe and uses Einstein's general relativity to compute how fast the universe was growing and expanding in the past. The expansion age measured by Wilkinson probe is larger than the oldest globular clusters, so Big Bang Theory has passed the important test. In the next video, we will talk about what happened next, the creation of stars and galaxies and so on. If you're still here, which means that your curiosity got best of you, thanks for watching this video. And if you further want to fuel your curiosity, kindly please subscribe and like this video, and I will keep you posting with new videos. If you have a different creation stories, what you got from your culture or the religion you follow, and how you perceive creation of everything around us, I would love to have discussion in the comment section below.